Hey everybody, so I had a question to do number 11 from section 9.8 for those of you working in the textbook. What we have here is it's asking us to find or evaluate the expression sine of a plus b for number 11. And what I've done here is I pulled up my sum formulas, and it's telling us in here that cos of a equals 4 over 5, sine of b equals negative 15/17, and it's telling us those intervals that those are on. So what we're basically going to look here is, well, we know sine of a plus b is just going to be sine of a times cos of b plus cos of a times sine of b. So we can see that we'll be able to plug in 4 over 5 here and negative 15 over 17 here. What we may now be wondering is, how are we going to find sine of a and cos of b? And that's a good question. Well, in the instructions on number 11, it's telling us that a is between 0 and pi over 2, or 90 degrees. And b is between 3 pi over 2 and 2 pi, which is 270 and 360 degrees. So basically, A is an angle in the first quadrant, and then B is an angle in the third quadrant. So if you think about it here, our cos value is the adjacent over the hypotenuse, or we often think of it the x value. So this may harken back to Pythagorean triples. And so if we know that this cos is 4 over 5, the cos of a is 4 over 5, then the sine of a has to be 3 over 5. And since this one now, we know that the sine is negative 15 over 17. Well, the cosine, this is another Pythagorean triple. The cosine we can see is positive, and that's going to be 8 over 17. So now we're going to end up multiplying quite a few fractions. So if I'm not mistaken, this is 85. And if I'm not mistaken, this would be 24 plus, this also ends up being 85, and this is going to be a negative 60, so it should be negative 36 85ths is actually what the sine of a plus b is. Let me check the answer key. Yes, that's the correct answer. So that was a tricky one, and it quite aligns closely with example 2 in the textbook. Read that over and watch this back. See if it gets tricky having these Pythagorean values. But remember, it all has to do, right? This is down, so it's negative. This is to the right, so it's positive. This is to the right and up, so they're both positive. And we're always keeping that distance of the hypotenuse positive, like we always consider the hypotenuse of the unit circle to be 1. Hope this helped.